Guys, welcome back to my channel, and today we are going to look at substitution ciphers. Substitution cipher, Python code for this. Okay, so let us first understand what substitution cipher is and why it is used for. Okay, so suppose uh, there is a secret message that has to be read only shared between only these two people. Okay, person 1 is sending to person 2. Person 1 can be thought of as Lord Voldemort, and he wants to uh, conceal his identity and want to share some secret information only to his accomplice, that is maybe Professor Snape. Okay, and they don't want their message to be read or understood by anyone else in the middle. Okay, a secret text of a possible attack to capture on the world, right? Attack on maybe some date. Okay, maybe uh, tomorrow, attack tomorrow at certain time, but they want to hide this information and they don't want the Harry Potter and other people to know. Man in the middle to read or tamper this text so that their plan of attack is failed. Okay, so how to encode this text so that only the people who are expected to know this secret, only they can read this and understand this text. That is what substitution cipher is all about. Okay, so the trick is the message attack tomorrow at maybe 8 a.m. Okay, the way to hide this or encode this text to in an unreadable form is maybe we are substituting all the letters by 5 units. So A will become an F, T will become, okay, the code is over here. We know what F will become after 5 encoding. Yeah. So every letter will be shifted 5 units, right? We can just print this T over here. Print this dictionary T. Okay. Okay. So this little T, small T, very small T. Yeah. P Q R S T. T will be substituted with small y. With small y. Y. A is F. C is what C is? H. Okay. So like this it will be encoded. So this text will be in an unreadable form. And if Harry Potter wants to stop the attack, he will have to, if he gets the note by uh, killing the messenger, still he has to try to figure out what this means. Okay, if he gets to know that some sort of letters are swapped or some are, it is shifted by some other letter, the pattern if he understands, then he will be able to read the and decode this text into English and understand what the evil team is trying to plan and stop them. Okay, so we will code this. Okay, the code, Python code for this is over here. um yeah, the Python code is over here. So before that we will try to understand the Python functions that will be used in this code. So this is the string, suppose hello world, and we can use the string dot replace any letter with some other letter substitutes. For example, if I want to replace this h with j, every h in this string with j, we will give the first argument as letter to be substituted, and the second with which letter it will be substituted. We are printing separately s, the new string s, and the old string h. So this replace function, it creates a new string with h replaced with j, but the old variable, old string is not changed. Okay, we are printing both s and h. Then first s is jello world, and h is still the same, hello world. It is not changing the original string, it is creating a new string with the replaced character. Then if you want to know the length of a string, you can use the len function. Okay, and then we can h was a string hello world, you can use list slicing to get only a substring of this string. For example, if I want to print the letters at index 2 to 4, okay, the end index is excluded, that is see, the letter is 0 1 2, right, 3 4. So till 4 it will be printing, like LLO it will be printing, and it's printing LLO. Okay, and now there is a we are importing the string library, and then we are using string dot ascii, okay, wait, string dot ascii underscore letters. Okay, because in substitution cipher we want to give an encoding substitution letter to every small a to small z and capital A to capital Z. So if this there is a variable, okay, that is ascii underscore letters in the string library, and we are converting it into a list and printing that, we will be using we will be writing small a to small z will be replaced by which character, and capital A to capital Z in which character. Okay, and now this is the code for the Caesar cipher. Okay, first we are writing the code for encoding in the text into a unreadable cipher text, and then we will convert it from unreadable form to readable form, and then we will analyze how hard it is for someone in the middle like Harry Potter to decode the text. Okay, so this is the definition Caesar cipher, and it is taking a string input. Then we are creating an empty dictionary over here. Why will this dictionary be used? It will be used to store every original letter will be substituted by what letter. Okay. Then we are creating the list of a string dot ascii underscore letters, list of all alphabetical characters, capital A to capital Z and small a to small z. Okay, to create a to keep a track which letter has to be substituted with what. Okay, then what we are doing is, so we are filling the dictionary with the shifted characters. Okay, so for I in range from 0 to length of this string, okay, whatever length this array has, we will uh, d of v of I means this, it will start from 0, right? The first letter will be a small a. So d of v of 0 means in the dictionary for the letter a, we will map it with the character in this set of alphabets. 0 plus 5 will be 5, right? The letter in the fifth index will be small f. Okay, so and why we are doing this modulo the length of this list, cause it might happen that I will reach 26, right? There are 26 character, right? I will reach 26 or I will reach the end of the list, okay, length of the list. Okay, and then what will happen after that length of list, that index does not have any letters, right? So what will happen, it will go to the start of the list again, because when you do modulo, it will give the remainders from 0 to the length of list minus length of list minus 1. It will give this index. And after you have reached the length of v, you have to go back to the starting index, and that will be your shifted character, right? So that our characters stay within the index of your letters. So we are doing a modulo operation. Okay, so what will happen, so for example, the 0th position v of 0 will be containing that original character, that will be an a, and then in a will be the key, and for a, I plus 5, that is 0 plus 5, or f will become your value, means a will be replaced with an f. Okay, then we are printing that with what letter every character has been replaced, the dictionary we are printing. Then for keeping the value of the encoded message, we are initializing an empty string. Okay, why we are doing this? Because if I use the replace function, what will happen, in every step a new string will be calculated, and for that may give some errors. Okay, so we are creating a new string in which we will append the encoded characters. Okay, so for every character in the original string, we are iterating the original message, English message, that has to be encoded character by character. We are iterating it. And then for every character, we are finding whether it is present in the dictionary or not, because we are substituting only the character alphabet, small a to small z, capital A to capital Z. Remaining numbers we are not encoding. Okay, so if that character is present in the dictionary, what we are doing, in the encoded message we are appending the substituted character for that character. है ना? In the dictionary we have kept a track, every character is replaced by what character. So d of character will be the value, or the character with which this character has to be replaced, and otherwise we are keeping the character same and appending in the encoded message. Unchanged character is appended in the message, and then we are returning the encoded message. Okay, and then we are getting the user input, the text to encode, and then call the function sees a cipher on string 1, and then print the encoded string. Okay, so let us run this once, and then we will see the code for, we will change this code only a little bit to see the encoded message, how can we can get back into again English language. Okay, the text to encode is maybe I am Lord Voldemort. Okay, press enter. So this is the scheme in which a original letter A will be replaced by F, B will be replaced by G, C will be replaced by H, and so on. And after encoding, our message becomes this. Okay, let us copy this message. Okay, I am copying this message. Copy, and then we will modify this code to get back the original English message. From I plus 5, I am replacing with I minus 5. Okay, and let us, yeah. So what we are going to do, from plus 5 I am changing it to minus 5 to get back the original string. Now we will run this code again. Okay, so now I will be pasting the substituted text to get back the English text. Yes, this is I am Lord Voldemort, right? Now suppose we would go with I plus 5 again. Suppose I am Harry Potter and I have to try to figure out this encoded message, what might be the encoding to crack this into English. So what I will do, I will think first ki maybe I will do I minus 1. Maybe every letter has been replaced by I, the letter, the next letter. That means A is replaced with a B. It might be the encoding might be A is replaced with a B is replaced with a C is replaced with a D, the next character. So one by one, I will try out every possible encoding, right? And what we will do is, now we will run this code and see if we are getting this was the encoded message that Voldemort is sending to every of his allies, and I want to decode this message. I will just press enter, but this message is still not making any sense, right? So now Harry will try, maybe every character is replaced by 2 ahead. That means A will be replaced by C, B replaced with D, like this may be the encoding. So he will do I minus 2 and try to make sense of the text. Now let us try to run this code till we get an English character, English message. So he will run this again. But still this message is not in English, not making any sense. Then he will try I minus 3, right? And then run this code again. No, it is not making any sense again. Still, he will try. Um, okay, I minus 4, right? And he will keep on trying for 26 plus 26, right? 26 plus 26, because we have small a to small z and capital A to capital Z. So 26 plus 26, 32 characters he will have to try. And that is very much possible with a modern computer, right? Until he gets the English message, English meaning, right? For that text. Now even he gets I minus 5, that message will make sense. So the worst case, what substitution can be there? Worst case, the substitution can be small a replaced with capital A. Now capital Z, that is the worst case substitution. Small a replaced with the capital Z, right? That is the worst case substitution. So one by one, Harry will have to try all possible substitutions till he get the English message for that encoded text. So it is very much possible. So in real world, as this encoding is not very hard to break for middlemen, the attackers or cyber hackers. That's why this is not being used. Better substitution can be that every letter is randomly assigned with some letter. Maybe A is assigned with a capital B, maybe randomly, and B is assigned with maybe a K. Okay, some random assignment. So that will be harder to break. C maybe J, because this does not have any pattern. Randomly any letter is assigned with any other letter, and the dictionary is passed on to all the allies so that they can understand the message. But uh, I will give you a story to explain to you this substitution. It looks harder than the previous one, but still it is easy. It is very much possible for Harry or any hacker to understand this code and make changes in this code, okay, and make it look authentic. Okay, the story is like this. There is a mom, and she has 10 kids. Okay, kid 1, kid 2, kid 3, okay, and so on. She has 10 kids, and all her children, they are of different heights. Okay, this is information is important. All the children are of different heights. Okay, so all of them, they hide their face. They decide they will wear a mask and hide their faces, and together they went to their mom, and together they told mom, can you tell which one is which one? Okay, can you tell, identify us, who is who? And mom, she's confused in the beginning little bit, but she uses the fact their faces are hidden. She doesn't know which child is who, which she cannot recognize by their faces. They are wearing masks, but she knows the information that every child is of different heights, and she makes use of that information to identify every child correctly. She knows that the smallest height child is Ram, then bigger than that, taller than him is Sham, so on. And she identifies them correctly. So, what is the moral of the story? What is the moral we can draw from the story? That we can use, as all the letters are substituted from another letter, or the letters are wearing a mask, but you can use some additional information to figure out the pattern in this encoding and decode this code. How? So, okay, English, there is a probability in English, any sentence of an English letter, the highest probable letter is the letter E. It is a fact. In any sentence, E is very highly used. So, if you find a pattern that is occurring very frequently in any encoded text, suppose this symbol is occurring multiple times, that means E is being mapped with this symbol, and you can identify that E is this triangle. Similarly, you can use some similar other facts. If the language encoded is in English, you can identify which letter is being substituted with what letter. So, isn't this so interesting? Okay. So, hope you like this video. Please share it with your friends, subscribe to my channel, and keep learning, keep coding. Happy learning. Bye bye.